Hello everyone, welcome back to the channel. I'm Preeti and in today's lecture we are going to start an important chapter from class 12 chemistry. Haloalkanes and the haloarenes. This chapter is very important because it introduces us to the chemistry of compounds containing halogen atoms such as the fluorine, and the iodine. In this chapter we are going to understand what are haloalkanes and the haloarenes, classification and nomenclature, nature of carbon-hydrogen bond, preparation of haloalkanes, physical properties, nucleophile substitution reaction and the elimination reaction, then polyhalogen compound and their application. So let's begin. So what are haloalkanes and the haloarenes? Let's start with the basic definition. When one or more hydrogen atom of an aliphatic or the aromatic hydrocarbon are replaced by halogen atoms such as fluorine, bromine or iodine, then halogen containing organic compounds are formed. Okay, so what is haloalkane? Haloalkane means halogen is attached to an sp3 hybridized carbon atom of an allyl group. Okay, so the halogens are fluorine, bromine or iodine. So the general representation of haloalkanes is Rx, where R is any alkyl group and X means halogens. Okay, like fluorine, chlorine, bromine and the iodine. Okay, for example, methane. Okay, that is CH2. Okay, so if one hydrogen of methane is replaced by chlorine, then we get CH3Cl, that is chloromethane. Okay, in alkane, replacement of hydrogen by halogen is called haloalkane. Okay. Now let's look at haloarenes. Okay, so halogen is directly attached to an sp2 hybridized carbon of an aromatic ring. Okay, so haloarenes are aromatic compounds in which a halogen atom is directly attached to an aromatic ring. Okay, so the general representation of haloarene is Rx, where R is aromatic ring. Okay, and X means halogen. Okay. For example, C6H6. When one hydrogen is replaced by fluorine, then it is haloarene. Okay, we can call this chlorobenzene. Okay, this is chlorobenzene. Okay, this is chloromethane. Okay, so in simple way, we can say that halogen is attached to an aliphatic carbon, and in haloarenes, halogen directly attached to an aromatic ring. Next is classification of haloalkanes and the haloarenes. So haloalkanes and the haloarenes can be classified in several ways. First, it is based on the number of halogen atoms. So first is monohaloalkanes and the monohaloarenes. So what is monohaloalkanes or the monohaloarenes means one halogen atom. Okay, one halogen atom. Okay. Next is dihaloalkanes and dihaloarenes means two halogen atom. Right. One halogen atom and two halogen atom. And what is tri? Tri means three halogen atom. Three halogen atom. Okay. So the example of monohaloalkane is C2H5X. Okay. Next is, and the example of monohaloarene is benzene ring, that is phenine and X. Okay. So this is the example of monohaloalkane and monohaloarene because in this compound. So the example of dihaloalkane and dihaloarene is CH2X, CH2X. Okay, this is the example of dihaloalkane, and for dihaloarene means in benzene ring, two hydrogen atom is replaced by the two halogen. That's why it is called as a dihaloarene and the dihaloalkanes. Okay, next is trihaloalkane and the trihaloarene means in this compound three halogen atom is present. Example of trihaloalkane is CH2X, CHX and CH2X. Okay. And the example of trihaloarene, trihalo Haloarenes is means 3 halogen atom. Okay. Trihaloarene means 3 halogen atom is present in that compound. Okay. So this is the example of monohalo, dihalo and trihaloalkanes and haloarenes. Okay. And if compound containing the several halogen atoms are called as a polyhalo compound. Okay. Fourth point is polyhalo compound means compound containing several halogen atom. Okay. So this is all about the monohalogen compound, dihalo, trihalo and the polyhalo compound. Okay. So let's classify them based on the carbon atom attached to the halogen. If the carbon attached to the halogen is connected to the one other carbon atom, then it is called as a primary alkyl halide. So what is primary alkyl halide? If the carbon attached to the halogen atom is connected to one other carbon atom, then it is called as a primary haloalkane. Example of primary alkyl halides are CH(X). Okay, means halogen atom is attached to the one carbon atom. Okay, then it is called as a primary alkyl halide. Next is secondary alkyl halide. If the carbon attached to the halogen is connected to two carbon atom, then it is called as a secondary alkyl halide. Okay. So the example of secondary alkyl halide is okay. This is secondary. Okay. Next is tertiary alkyl halide. So if the carbon attached to the halogen is connected to 3 carbon atom, then it is called as a tertiary alkyl halide. So the example of tertiary alkyl halide we can represent it by 3. Okay. So in primary alkyl halide, carbon attached to the one carbon, and in secondary alkyl halide, carbon attached to the two carbon, and in tertiary alkyl halide, carbon is attached to the 3 carbon atom. Okay, it is attached to the one carbon atom, then it is attached to the 2 carbon atom, then it is attached to the 3 carbon atom. Okay. So this classification becomes extremely important when we study SN1 and the SN2 reactions. There are two special types of halo compounds that we should remember: allylic and the benzylic halide. Okay, so what is allylic halide? When the halogen is attached to a carbon and this is the carbon-carbon double bond, then it is called as allylic halide. Okay, when halogen atom is attached to a carbon adjacent to a carbon-carbon double bond, then it is called as allylic halide. Okay. So what is allylic carbon? Allylic carbon means CH2X. Okay. So this carbon is allylic carbon. Okay. So this carbon is allylic carbon. Okay. As example of allylic carbon is X. Okay. So this carbon, okay, this center carbon of double bond and halogen atom is called as allylic carbon. Okay. So what is benzylic halide? When the halogen is attached to a carbon directly adjacent to a benzene ring, then it is called as a benzylic halide. Okay. When the halogen is attached to a carbon directly directly adjacent to a benzene ring, then it is called as a benzylic halide. Okay. So the example of benzylic halide is CH2X. Means halogen is attached to a carbon directly adjacent to a benzene ring. Okay. In aniline and the benzylic halide, the halogen atom is attached directly with the sp3 hybridized carbon atom. Okay. Next classification is based on the carbon attached to a halogen. But compound containing sp2 carbon halogen bond. Okay. So what is vinylic halide? These are the compounds in which halogen atom is bonded to a sp2 hybridized carbon atom of carbon-carbon double bond. Okay. So the compound in which halogen, that is X atom, is bonded to a sp2 hybridized carbon atom of a carbon-carbon double bond. Okay. So what is vinylic halide? So the example of vinylic halide is X, means that halogen is directly attached to a sp2 hybridized carbon atom. Okay. In this compound also that X is attached directly with the sp2 hybridized carbon compound. Okay. Next is aryl halide. These are the compounds in which a halogen atom is directly bonded to a sp2 hybridized carbon atom of an aromatic ring. Compound in which X atom, that is halogen atom, is directly bonded sp2 hybridized carbon atom of an aromatic ring. Okay. So the example of aryl halide is in aromatic ring. Halogen is directly attached to sp2 hybridized carbon atom. Okay. This is the another example. Okay. Means that halogen atom is directly attached to sp2 hybridized carbon atom. So this is all about the haloalkanes and the haloalkanes. That's all for today's class. We will continue in the next class. Until then, take care. Bye.